Okay, why this complex fraction is included in this unit, or this section 8.2 and not 8.1, is because of the separate fractions in the numerator and denominator, so it still ties in with finding a least common multiple or a least common denominator. And there's different ways to work through these. I'm going to show you the way that I think is the most efficient and the easiest to understand, but just know, and this goes for anything, if the way I'm describing it doesn't quite make sense, I can show you an alternative way to do it. So in first looking at this, I want to find, for the, not the overall fraction I have, but the fractions within the big fraction. So the 1 over a, 1 over b, 1 over b, I could make this one a fraction as well by putting it over 1. So I have 4 different denominators, or 4 denominators, a, b, and 1. I want to find the least common denominator of those 4. So what would the least common denominator be for those 4 fractions? Or the least common multiple of a, b, and 1? Ethan? Just 1 AB, yep, or just AB. You wouldn't even need to include the 1 in front. You certainly can. So that's tying into what we talked about yesterday. Find that least common multiple, least common denominator. And now, for the overall fraction, I'm allowed to multiply a fraction by something as long as I'm multiplying by the same thing on the top and the bottom, because then it's like I'm multiplying by a 1. So I'm going to multiply this fraction by the least common denominator on the top and the bottom of the big fraction. So then, by doing that, and I'm just going to include parentheses around the numerator and denominator because I will need to distribute, this AB that I'm multiplying by is like AB over 1. So when I distribute this to the 2 fractions on the top, the AB is getting multiplied by the numerators. The denominators are getting multiplied by 1. So I'm not multiplying all of these the smaller fractions, top and bottom, by AB. I'm multiplying by AB over 1. So the top will become, if I multiply AB times 1 over A, I would have AB over A. And then if I multiply AB by 1 over B, I have AB over B. And then on the bottom, I can distribute AB as well. So I have 1 over B times AB again, so AB over B. And then minus AB times 1, which would be just AB, or if you wanted to write it as AB over 1, you could. So I still have 4 fractions, but now, because I multiplied by the least common denominator, which is the least common multiple, I should be able to simplify these 4 fractions so that they are not fractions anymore. I will still have an overall fraction, but I won't have all of the separate fractions within it, so I won't have a complex fraction. So in that first fraction on the top, the a's will cancel out, so that would just be b. In the second fraction, the b's cancel out, so that's just a. On the bottom, the first fraction, b's cancel out, so that's just a. And then the last fraction, I didn't even need to write as a fraction, it's just over 1, so it's just ab. So then I would have b plus a on the top and a minus ab on the bottom. So I no longer have a complex fraction. I still have a fraction, but I don't have fractions within it. Okay, so any questions how I got to here? I'm not canceling out terms. So in this fraction, if I have a times b and then a, these a's would be factors for that small fraction. Because this on top, this is a times b in that one fraction. So it is a factor, not a term. So you are right. I can't cancel terms. So that would be in this fraction here. These a's I can't cancel because those are terms. Does that make sense? Okay. So then once you get to here, like I just said, don't start or don't keep canceling unless you can cancel common factors. So again, these a's are not factors, they are terms. This a is being added to b. This a is also being added to a negative ab here, so they're not factors. If it helps, you can put parentheses around it so you know that you shouldn't cancel anything within those parentheses. It is possible in this last step, though, that there is more you could do to simplify. So this either could be your answer, or you need to just make sure it's in simplest form. So the only way to check if you can still simplify is if either your numerator or denominator could be factored so that something cancels out. So would I be able to factor the top at all? I see some no's. B and A, they have a GCF of 1, but that's not going to change it if I factor that out. How about A minus AB? I could factor that. There's a GCF of A. So I'm still going to have B plus A on the top, and on the bottom, if I factor out the A, then I have 1 minus B. So everything is factored. Even though I factored the denominator, I still am not able to cancel anything. So this is the simplified answer. Or that also means I could have just left my answer how it was in the step before. That would also be fine. But if you are not sure, is there something I can cancel? Is there not? Then factor anything you can to see if anything cancels out. It's just a way to check if you can still cancel something. Okay, so any questions on that? So a complex fraction is never simplified. If you have fractions within another fraction, that is not simplified. So that's why we are doing this process to no longer have a complex fraction. And then all common factors are canceled out. So I'd like you to work through example 2. Simplify example 2.
I'll make it plus.
All right, so I think everybody's okay in terms of checking, but just double check. You could actually have either of these as your final answer. You wouldn't have to have the factored form since when you factor, you can't simplify anyway.